our digestive system. This is going to be a fun chapter. Maybe you're listening to this and looking at your screen as you're snacking or eating breakfast, lunch, or dinner or something like that. Maybe you're just sipping on some water. So this will be an interesting chapter for you as you continue to do that. First of all, under the introduction on page 681, did you know that a normal adult, whatever normal is, we eat about 40 tons of food in our lifetime? Now, I know everybody has a different length of time that we live and we eat different foods, but in essence, it's an average of 40 tons of food. That's a lot. And the digestive system is the disassembly line that is going to help take apart or process all of those things that we eat so that it can go out into our body as molecules and out into our cells so that they can be fed. Sometimes we eat things and it makes us tired. So our digestive system can be a part of our parasympathetic division of our central nervous system. You want to go back to chapter 23 to remember what that parasympathetic nervous system is, or that secondary part that we talk about there. Sometimes when we eat, we do need to rest, right? As all of our food is digesting. So in the disassembly line that we are going to talk about in this chapter, starts with our mouth, goes to our pharynx, our esophagus, stomach, small intestines, large intestines. But we will also talk about the liver, the gallbladder, and the pancreas. I've mentioned those in some other chapters, and we will have some of those still in our urinary chapter. But we're going to talk about them as far as the disassembly line that they're a part of. The functions of what you are eating. Very important functions that start with taking in whatever material we're taking in and then getting rid of it or eliminating what our body does not need or that unabsorbed material. So please know all 5 of the physiology or the functions of our very important gastrointestinal tract. This picture is what is on page 682. Probably you're going to be referring to this picture more than not because it's an overall view of the entire system. We have some close-ups that we'll look at as well. But we just want to look at what the gastrointestinal tract is. Notice that it's also called the alimentary canal or the digestive tube or the GI tract. All of those things are the same. But we again have those extra organs, the saliva or salivary glands, the pancreas, the liver, the gallbladder. We will talk about those and the process that it does to help with our entire anatomy or our disassembly line. But those will be coming up at the end of the chapter. On the right-hand side of this screen, you have the peritoneum picture, which is on page 683, the left-hand side. And we want to look at this picture to look inside our abdominal cavity. So this is where the serous fluid is being secreted. That's helping to keep our organs so that they're not sticking to each other. The entire peritoneum is an anchor for all of our digestive organs. It has our blood flow, our lymph vessels, so just everything that is needed so that our abdominal cavity stays healthy with all that stuff that we're putting in our body. When you look at this picture, on the upper right-hand side, you will see the lesser omentum, and on about the middle of the left side, or about on the belly button, you will see the greater omentum. So both of these areas are layering that are containing some of the fat, but it's also part of what's extending out from our stomach and our intestines. So it's just parts of the entire peritoneum, membranes that are located within there. They're just kind of the extra layering that we need. And sometimes we can fill up with fluid within the peritoneum. So we want to be aware that sometimes that's something that can happen within our bodies. You can keep this screen up, or if you want, you can look at the picture on page 682. We're going to start with our disassembly line, which starts with our mouth or our oral cavity. So this is the first part of our GI tract. This is where we chew our food or our food becomes masticated. So that's just breaking it down between our teeth and our tongue. So just what happens there. If you go down into the second paragraph under the oral cavity, it gives us the term bolus. So when we put something in our mouth, it mixes with our saliva and it becomes a bolus, or a small round mass of food. But what happens within our saliva is what we want to look at. So what's in our oral cavity? What saliva glands are happening or what they're doing to help with our breakdown? So our saliva, this is on the bottom of 683, our saliva has digestive enzymes, salivary amylase, lingual lipase. I want you to be familiar with what each of those done, because one is helping with carbohydrates and one is breaking down the lipids, the fatty acids. So please be familiar with those two secretions that are within our oral cavity or what our saliva is made up of. The next part that we're moving on to is the pharynx. So back in the respiratory chapter, you might remember the pharynx, and you can look at the picture on 682 to see where the pharynx is. So this is our throat region. So this is part of what happens when we swallow. So you will notice on the bottom of 683 under pharynx that there is a word that means swallowing. It is in italic, it is not in bold, so please make sure that you notice it there. But our bolus of food needs to be propelled down, and that brings us to our peristalsis. So the picture of peristalsis I have on the screen, or you can see it on the top right hand side of 683. So this is what happens to that bolus of food as it goes down into our throat. The contractions behind the bolus are propelling it forward and moving it further down into our esophagus, which will be the next part of our disassembly line. So peristalsis is just that smooth muscle contraction moving that food down further into our GI tract. So our esophagus is next, so it's below the trachea. It's transporting whatever that bolus is or the liquids from our pharynx down into our stomach. There is a point at the end of our esophagus that is a sphincter. A sphincter is a round ring of muscles or a ring of muscles that's round, and it has to open and close so that whatever is in that bolus or that liquid can come into our stomach, or perhaps it says, no, I don't want to let it in right now. So that lower esophageal sphincter opens and then closes, permitting things to enter. But it also can be, that lower esophageal sphincter is also called the cardiac sphincter, because sometimes when people eat too much food, that sphincter gets overworked. And it feels like you have something going on with your heart, but it's really just trying to open up big enough or maybe fast enough to let those things down into your stomach. Our stomach is the next part of our disassembly line. So you can see a better picture in your book on page 684. So you can see the esophagus at the top, that lower esophageal sphincter, the LES, is right at the end of the esophagus, right at the top part or the most superior portion of our stomach. So that entire J-shaped organ is our stomach, and it's located between the esophagus and the small intestines. The small intestines will be our next part. But what I want you to notice about the stomach is that it has three main regions: the fundus, the body, and the pylorus. So you can see each of those on the right-hand side around that outward curvature. And the inside of our stomach, it has to be able to expand depending on what we put in it. And that is the term rugae. We will also have that term when we have our urinary system, because the same type of muscle layering is inside our urinary bladder. But rugae just is what allows our stomach to get bigger and then come back into whatever size is normal for it. So not only will we find that rugae in our bladder, but also in our gallbladder. But again, we'll talk about that here shortly. So I want you to know the lower esophageal sphincter, the fundus, the body, the pylorus, the term rugae, but then also, this is the second paragraph on the bottom of 684, there's the word in bold, it's chyme. So this is the substance, that semi-liquid, nasty acid that's in our stomach that is churning our food around. So when whatever we're eating mixes with our gastric juices, it's enzymes, it's acid, it's really nasty stuff. You've probably burped it up along the line somewhere. So it's that chyme. The chyme is what actually passes through another sphincter, a ring of muscles called the pyloric sphincter, that is at the very bottom or the end of the stomach and is going to go down into our small intestine. So you can see the pyloric sphincter, that's the end of the stomach in that picture. The secretions that are going on inside our stomach, not only are they kind of icky to taste, that acidity, but there is also some other glands that are producing some protein, some things, some hormones, some mucus to break down all of those things that we eat. So the secretions that are on the bottom of 684, we have pepsin, hydrochloric acid. Onto the top of 685, we have gastrin and an intrinsic factor, which is part of our B12 vitamins. So all of these secretions are collectively referred to as the gastric juices because they're produced in our body based on what we normally are putting in our body. So if you've ever eaten something and it took a while and you're like, I don't know if that really agreed with me, it could be because your body has not been introduced to that and it didn't know what type of secretions to produce. It needed to kind of process through and say, how about this one or how about that one? So sometimes that happens. But then also, we get used to what we're putting in our stomach. So if you're not used to eating something greasy or a fried fatty food or something, then it also can take time, even though maybe you ate that a year ago, but your stomach is really just trying to take in all of the substances that we're putting in there and produce all of those juices based on whatever it is we're putting in there. So before we move on to the small intestines, on the right-hand side of the screen, or this is also on page 687, I want to just look at what the stomach is in charge of absorbing. And you'll notice the small intestines and large intestines are on here as well. But the stomach itself is taking in 20% of alcohol, if there is some ingested, calcium, magnesium, iron, and it also is in charge of breaking down whatever medications, whether they're liquid or a pill form or a capsule. Those gastric juices have to break down all of those things. So this is a small portion of what we're putting in our body is being absorbed or processed through and out into our body from our stomach. The small intestines is up next. Now, the best picture that I can show you of the small intestines, because there's not real good ones, on page 686 is the view that I have here. So notice in A is where they're showing the small intestines. The other are the magnified view of the pieces or parts of the small intestines. But you can also look at the picture on 682 and see the small intestines. It's not small because it's this teeny tiny thing. It is called our small intestines or our small bowel because it's thin or it's smaller. It does take up a very large portion of our abdominal cavity. It is actually taking up more space than our large intestines. And our small intestines, it really gets a bad rap because it is the most one, if not the most important part of our body being able to thrive. So the small intestines is longer than the large intestines. The small intestines is about 20 feet long. So if you look at those pictures on 682 or you look at that picture on 686, that's a whole lot being shoved into a little space that has to maintain all of our digestive food. So within the small intestines, this is where the nutrition is happening. This is where the absorption is happening. And before we go off into the parts, look back at that picture on 687 and look at the things that are absorbed in the small intestines. Glucose, fats, fat soluble and water soluble vitamins, sodium, potassium, B12, alcohol, 80% of our alcohol, amino acids. So a lot of the things that our body really needs. So our small intestines is super important for that. If you look at the picture on 684, and you can remember that we talked about the pyloric sphincter. So this is where the stomach ends and the small intestines begins. So the important chemical digestion and absorption of this food is starting right after that pyloric sphincter. The small intestines has 3 sections within it. So they are at the bottom of the screen or the bottom of page 685. The 3 sections are the duodenum, which is the shortest, the first and the shortest section. It's only 10 to 12 inches long. This is where the liver, the gallbladder, and the pancreas are going to be coming off of, and we're going to look at a picture of that here shortly. The jejunum is the next part. The next 7 to 8 feet is that portion. And then the last part is the ileum. So this is the longest section. It's about 12 feet. And this is where we have lymphatic tissue, our Peyer's patches that we talked about in chapter 27, our lymphatic chapter. So those Peyer's patches are located there. So all of those portions, those 3 sections of the small intestines, you definitely need to know. And at the end of the small intestines is the ileocecal sphincter, and we'll talk about that right before we get into the large intestines. I want you to look at the bottom left-hand side of page 685, right after we just talked about those 3 sections of the small intestines. They're giving us more definitions of terms that you want to be aware of, not just because they're in italic, but because they are very important for what we need to know. So there's folds and little finger-like projections that are coming off of the inside of our small intestines. So in your book on page 686, you can look at that top picture and look at the little villi, the folds, which are the little circular, like the hills and the valleys or the mountains and the valleys. So all those little projections coming off there are for something that's really important. That's where our blood capillaries, our lymphatic capillaries are located, and those little finger-like projections are part of absorbing our nutrients. They're processing things, sending out to where it needs to go to be distributed out our body. But it's also helping us absorb the fat that we need, but then also sending even more things out into our body. So again, the small intestines gets a bad rap. We just don't think of it as much because we always think about, when we talk about our intestines, we think of our large intestines. But let's look at all the different secretions that are happening within our small intestines. So again, has to do with all of those finger-like projections. Look at the list under secretions of all of the things that our small intestines is helping us with our digestion and absorption. Again, super important. So fat digestion, just our hormones, telling our gallbladder and our pancreas what to do. Also trying to neutralize some of our stomach acids, trying to make them less acidic, more alkaline. So all of those substances are helping all of our digestion. So please be aware of all of those secretions that are happening within our very important small intestines. One of the reasons I wanted to put together my own slideshow was because some of the things in the book are not right next to the pictures, and I think the pictures definitely help with our understanding. So next we're going to talk about the large intestines. The picture is in your book on page 688, but they start on the bottom of 685 with the definitions and then goes under 686. So it's a little bit easier to either look at the screen or to then look back in your book and know what you're seeing. So the large intestines is also called the large bowel, which like the small intestines is called the small bowel. And it begins with that ileocecal sphincter. So again, a sphincter is what type of muscle? And then our large intestines ends when it runs out of our body at our anus. So from start to finish, we've started with our mouth, well, now we're down to the very last part. But what our large intestines is in charge of, or what it's secreting out into our body, is also important, not to belittle what it's doing. So if you look on 686 at the bottom, or you can look at the picture on 687, we have some more sodium, we have potassium, we have water, we have electrolytes, but also there is some things that are forming within our large intestines, which is the stuff that we no longer need, and we have to eliminate what is coming out. So the large intestines is just like the small intestines. It is divided up into sections. So definitely easier for you to see those sections on page 688. So perhaps you want to look at that, or you can follow along on the bottom of 686. So we have the cecum, the colon, the rectum, and the anus. The cecum is at the very beginning, and the appendix is hanging off that, the variform appendix. Then we move to the ascending colon, the transverse colon, the descending colon, and then the sigmoid colon. All of those are defined on the bottom of 686, but it's almost easier to look at the pictures. So you can see where the ileocecal sphincter is. They have part of the large intestines cut open there. Then the cecum is hanging off that, and then right out of the cecum is the appendix. We all are probably familiar with our appendix. Then we move up to our ascending colon. Now, if you're looking at the picture, one thing that you're seeing there is the hepatic or right colic flexure. So that, if you look at it, it's kind of a turn. So it's a curvature that is called a flexure. So this is where the colon moves from right to left. And then it kind of dips down a little bit. It's the transverse. So transverse, when we talked about the planes way back, that's dividing us horizontally. So the transverse colon is going from the right to the left. When it gets over to the left, it has another curvature. It's the splenic or the left flexure. So again, it's taking another turn as it becomes or moves into the descending colon. So it's going to descend down. I want you to skip to the sigmoid colon because that's the next part. It also has a flexure. The sigmoid colon is kind of a little S shape because it has to go around in our abdomen. And then it comes to our rectum, which is the next portion, and then all the way down to the external anal sphincter. We also have an internal sphincter, and then the anus is at the very end. The part that I skipped in between the descending colon and the sigmoid colon, if you're looking at the picture on 688, that is the haustra. So these are little pouches which are giving our large intestines kind of that segmented or that rounded curvature. What happens within there is that these haustra are trying to move from one to the next because the same type of peristalsis, the term that we had a couple screens ago, the same thing is happening because there is muscles within our large intestines that are moving it forward. So the wall of our large intestines has some muscles and it's trying to move everything through. Part of what happens within our large intestines when we think of what is happening there, is things can get stuck in those haustras, maybe a seed, popcorn seed, a pumpkin seed, or something like that. And that can lead to infections or different things happening within our large intestines. And that's probably why it's a little bit more common when we think of our intestines. We think of our large instead of our small. But again, don't discredit what's happening within the small intestines versus the large intestines. So we've made it from our oral cavity all the way down to our anus, but we did mention that we have those accessory organs that we want to talk about. So the picture on the left-hand side of your screen is what is on the bottom of 688. So it's just showing where the pancreas, the gallbladder, and the liver are located. Now for a little different view, you can turn back to page 682 and look at the liver, the pancreas, and the gallbladder on that view. So you can see just where they're located. The stomach is perfectly shaped to fit within the pancreas and within the liver. So it's just an overview of where everything is located. So we're going to start with looking at the first accessory organ, which is the liver. So probably you recognize that the liver is extremely important to our body. It is the largest organ within our body. It weighs about 3 to 4 pounds, so it is big. And even when you look at the pictures of on page 682, you can see the liver is pretty big there. On page 687, under the liver portion, it lists out 7 different functions of the liver. I would advise you to be familiar with all 7 of those. And as you read through them, you can see our liver is extremely important for the nutrition that goes on within our body. The other thing that I want you to remember is that liver is hepatic. So when we were talking about the large intestines just a moment ago, we talked about the hepatic flexure, so that curvature. So right where the hepatic or the right flexure is occurring, that's also where our liver is located. See, it all kind of comes together there. So please be familiar with what is happening within the liver or the physiology of what the liver is. The one secretion that I want you to be aware of out of the liver is bile. So bile is produced within our liver. So this is what's breaking down the fat, the fatty foods that we take in. So that bile that is being produced. It's made in the liver, but it's stored in our gallbladder. And that's our next little accessory organ. So our gallbladder has the same type of rugae in it, just like our stomach did. It can get bigger, it can come back down in size, but it also is just the storage unit for that bile that the liver has produced. So it makes it a little easier to break down things, or kind of when you go to the storage and you get something out of it. So that's what the gallbladder is for. We can't live without our gallbladder. It just means that there's nothing in storage. It's like when we have no money in the bank, right? So that type of thing can happen. There is a very important substance that is produced, or I'm sorry, that is within the gallbladder to help break down that bile. That's the cholecystectinin. Sorry, my mouth doesn't always work right, but that's what is secreted from the small intestines as it's moving through that portion of the gallbladder. Excuse me. So bile is being transported by a little duct in between the liver and the gallbladder. So it kind of looks like a little green sac. Right below the stomach, or on the right-hand side of your screen, is our next accessory organ, which is our pancreas. We talked a little bit about the pancreas back in chapter 24, which is our endocrine chapter. Our pancreas has both endocrine and exocrine functions. If you can't remember what those are, you can turn back to chapter 24 and look those up. But the pancreas itself has some really super important jobs. So the pancreas has those alpha and beta cells. Again, we talked about those in chapter 24 because they're helping to break down the glucagon and the insulin that we're taking in our diet. And these digestive enzymes are being produced from the pancreas and going into the duodenum. So I didn't mention the duodenum, or I'm sorry, we did mention the duodenum when we were talking about the small intestines. So if you turn back to page 684, we have the stomach, the pyloric sphincter, and the very first part of the small intestines was that duodenum. So our pancreas and that duodenum are talking back and forth. So if you look at the right-hand picture, which is on page 689 in your book, right where it has the capital letter A, and if you go right up from there, or you have the common bile duct at the top, and then the duodenum right next to it. So that's our small intestines. And then look how coming out of about the center of the duodenum, there's that different green, kind of a lime green color that is going all the way through the very center of our pancreas. And notice all the little branches that are coming off of it. So those little ducts are the tubes that are transmitting the alpha and the beta cells, which are helping to break down the insulin and the glucagon for what we're taking in within our body. The enzymes that the pancreas is helping us with are listed under secretions on 688. No, you do not have to memorize those, but I do want you to be aware that the pancreas is part of what is breaking down what we put in our body.